Well, hey, welcome back to another day on It's Learning. So what I'm going to ask you to do is the drill, which is asking you to simplify these radical expressions. Remember, there's a couple of different ways you can do it. You could know what your perfect squares are and plug those in. Since we know 125 is 25 times 5, we could say, okay, I'm going to write that as 25 times 5n. So you can have the square root of 25 times 5n. We know the square root of 25 is 5, so then we have the 5n, which we don't know the square root of, which gives us 5 square roots of 5n. Again, you can do that multiple ways. For 216v, you could do a prime factoring. I know 216 is 108 times 2. I know 108 is 9 times 12. I know 9 is 3 and 3. I know 12 is 2 and 6. And I know 6 is 2 and 3. And I got this 2 up here. So I'm looking for pairs, so I would have a 3, pair of 3s, and a pair of 2s. So 3 times 2 would be 6 on the outside, and then the square root on the inside would be 3 times 2, which would be 6. And since our v was to the even, we would have, or to an odd power, we would have a v on the inside. So it's really a matter of choice which you want to do. So 512, I know that's 256 times 2. And I know that the square root of 256 is 16. K squared, I know, is k times k. So since I'm looking for a pair of k's, that would go outside. So I'd have 16k, and then the only thing left would be the square root of 2. Again, I have 512, which is 256. So I'd have the square root of 256. And I'd have m squared, because that's an even power. And then what are my leftovers? Well, my leftovers is 256 times 2. And m squared times m gives me m cubed. So the square root of 256 would be 16. The square root of m squared would be m. And you could follow these the rest of the way through. The square root of 216, if you go back and refer, we already know the square root of 216 is 6 square roots of 6. But here we have k to the 4th. The square root of k to the 4th is k squared, so we'd have 6k squared and the square root of 6. Now if you're struggling with these, you might want to go back to the It's Learning page 1 and look at how to simplify radicals, or you might want to ask me for some help. That's not the bell to dismiss you, that's just the bell that rang while I was recording. Okay? So our objective today is to learn to simplify radical expressions to add, subtract, and multiply radical expressions. So that's what we're going to do, add, subtract, and multiply. Just a couple reminders. All right, in the product and quotient rule of radicals, I want you to notice that the ends, the roots, have to be the same. If the roots aren't the same, then we have to get a common root, like we did last class, where we had to rewrite them as rational expressions and get a common denominator. So here, if they have the same root, you can just multiply inside times inside, outside times outside. So the ones we're going to do today, we're all going to have the same root. And the same is true for the quotient rule. The quotient rule, they have to have the same root to be able to be rewritten. Okay, so the roots have to be equal, and because of that, the square root of b can't be 0 because we can't divide by 0 because that's a danger number. So we're going to simplify these square roots. So since these are both square roots, we have the square root of 7 times the square root of 3. We can multiply 7 and 3 together and get the square root of 21. Then we have the cubed root of 9 and the cubed root of 3. Cube root, they're the same. So we can multiply them together. So we have the cube root of 9 times 3, which is the cube root of 27. And the cube root of 27 we know is 3. We also know back here, because of the square root of 21, 7 is a prime number and 3 is a prime number, so we can't break this down any further. Okay? Taking a look at the next one, we have the square root of 2x and the square root of 8x squared. So again, they're both square roots. So we're going to multiply 2x times 8x cubed. 2 times 8 is 16. X times x cubed, x to the 4th. What's the square root of 16? 4. And the square root of x to the 4th? X squared. So that's the easy ones, when they have the same roots, and that's what we're working with today. So here's a couple more practice. This time we have the 4th root. So we're looking at the 4th root, but again, they're both the 4th root. 4th root, 4th root. So since we're looking at the 4th root, we're going to multiply 8 times 2, still 16. B to the 5th and b to the 11th. Well, when we're multiplying the bases, we add the exponents. So that's the square root, the 4th root of 16 to the 4th. And remember that we could write that as 16b to the 16th, all to the 1/4, because we know the 4th root of 16 is 2. 16 times 1/4, power of a power, is 4. So we're going to have 2b to the 4th. Now we have a quotient. So we have the 4th root of y to the 12th divided by 81. So we can break that into the 4th root of 12 and the 4th root of 81. Well, the 4th root of 12, again, you can write that as y to the 12 power divided by root. 12 divided by 4 is 3, so we're going to have y to the 3rd. And the 4th root of 81 is 3. I feel like I should write this in as a rational exponent, in case people are wondering. Okay? So then we have the cube root of x divided by 125. So we can write that as the cube root of x and the cube root of 125. Cube root of x doesn't simplify, but the cube root of 25 does, because 125 is 5 cubed. So we're going to take the cube root of 5 cubed and we'll get 5. It's okay to leave a radical in the numerator, but we're not going to leave radicals in the denominator. Now, it might be helpful, we talked about this last class, to memorize these powers. So why don't you take a second, see which ones you remember, pause the video, come back and check it. Welcome back. I hope you got these all right. If you didn't, make your corrections. Okay, so when we simplify radical expressions, this allows us to break things down into what we know and what we don't know. So if we have the square root of 20, well, the square root of 20, we're looking for a perfect square that goes into 20. The square root of 20 is the square root of 4 times 5. And the square root of 4 is 2, and we don't have a nice pretty number for the square root of 5. The square root of 75, well, the square root of 75, that's the square root of 25 times 3. The square root of 25 is 5, and we don't have a nice pretty number for the square root of 3, so we have 5 square roots of 3. And then looking at the last one, we have the square root of 8x to the 5th. Well, 8 is the square root of 4, and the 2. X to the 5th is x to the 4th times x. Well, the square root of 4 is 2. The square root of x to the 4th is x squared. And then we don't have square roots for the others. So remember, those people without partners, they stay in the house. Ugly don't come outside. Okay, so we have the square root of 32, x to the 7th, y to the 9th. Well, 32 is 16. So I'm going to have the square root of 16. And I'm going to have the square root of 2. X to the 7th, I need an even number here, so that'd be x to the 6th. Then my leftovers. Y to the 8th, and my leftovers. So the square root of 16 is 4. X to the 3rd, and the square root of y to the 8th is y to the 4th, and then our ugly stays in the radical. The cubed root of 40. Now this time we're looking for perfect cubes. So I have to know what my cubes are. My cube root of 40, I know that's the cube root of 8 and the cube root of 5. I don't know the cube root of 5, so I do know the cube root of 8 is 2, so I have 2 cube roots of 5. You're probably saying to yourself, how does she know this? Well, I'm 46 years old and I've been teaching math for 23 years. Wow, that's half my life. Wow. Okay, so yeah, so let me rewrite this so it's a little clearer. There we go, that's much better. I just had that emotional moment there. Again, we're doing the cubed root, so I'm looking for 54. Well, my cube roots, I have 1. Cubed is 1, 2 cubed is 8, 3 cubed is 27. So I know the cubed root of 27 and the cubed root of 2. The cubed root of 27 is 3, and the ugly part is the cubed root of 2. So then we have the cubed root of 216, and then x to the 16th. Well, 216 is a perfect cube. The cubed root of 216 is 6. So I know I'm going to have a 6. X to the 16th, that's not a multiple of 3. 16 divided by 3 gives me 5, so I'm going to have x to the 15th, and then I'm going to have a cubed root of x left over. So my final answer would be 6, x to the 3rd, I'm lying, x to the 5th, because 15 divided by 3 is 5, and then I'm going to have this ugly cubed root of x left. I would like to point out a couple of things that you may or may not notice. Every time I write this, I write my radical, the leftovers part, last, because I don't want anybody to think that this numbers that are outside should be inside. So we want to make sure when we plug it in, they can tell what the actual root is and what's left in the radical. 250, well, 250, looking for cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Hey, so the cubed root of 125 and we would have the cubed root of 2 left over, right? Because 2 times 125 gives us 150. X to the 7th, we're looking for multiples of 3, so we would have a y, an x to the 6th. Ah, suckhead. I'm going to write my y first. And I'd have a leftover x over here. So the cube root of 125 is 5. The cube root of x to the 6th is x squared. The cube root of y to the 30th is y to the 10th. And then we would have the cube root of 2x left over. Okay, so that's how we simplify. Adding and subtracting radical expressions, like radicals, have the same root and the same radicand. So in other words, if I see the square root of 2 and the square root of 2, those are equal. So if I'm adding those, I would say 1 square root of 2 plus 1 square root of 2. That would be 2 square roots of 2 because I'm combining like terms. Radicals may be added or subtracted by combining the coefficients, just like we did here. So we had a 1 and we had a 1. Well, if we had had a 9 and a 3, then this would have been 12, right? In some instances, unlike radicals can be combined by first simplifying so that the radicands may be the same. So for instance, you might have something that says the square root of 8 plus the square root of 2. Okay, well, this is the square root of 8, the square root of 2, they're not the same. But I do know that 8 has a square root of 4 in it. So that could be the square root of 4 is 2, and then the ugly is 2, plus the square root of 2. So now I have the same radical and radicand. These are the same. So that would just add up to be 3 square roots of 2. So let's take a couple practice shots. OMG, this looks awful. Miss Finney, you crazy. You so crazy, girl. Girl, what's up with you? What you drink for breakfast? You didn't have no Smarties, did you? Man, whatever you taking, you better stop. All right, so anyhow, we're going to combine like terms. So what are our like terms? Well, we have a 7 square roots of 2. Do we have any other square roots of 2? Sure. So 7 plus 1 is going to give us 8 square roots of 2. Okay, then we have this 4th root of 5. Do we have any other 4th roots of 5? Yes, Miss Finney. Thank you. I love it when a class participates. So we have 1 plus the 4th root of 1 4th root of 5 plus 14 4th roots of 5, which gives us 15 4th roots of 5. I know you're excited. So let's take a look at another one. This time, everything has a 5 in it. So can we just put them all together? No. Why not? Right, because they have different roots. When I take a look here, I have 7 cube root of 5, and then I have a negative 8 cube root of 5. So 7 minus 8 is a negative 1. So I have a negative cube root of 5. Then I have 4th roots of 5. Negative 10 and a negative 14, 4th roots of 5. Well, negative 10 minus 14 is a negative 24, 4th roots of 5. I know, it's pretty impressive. But you can do it too, just keep practicing. Oops. All right, so we got to look, do we have any of the same like terms? No. But we do know that 18 is really the square root of 9 times 2. The square root of 9 is 3. So we have 5 square roots of 2 plus 2 times 3 square roots of 2. Because the square root of 18 is 9, which is the square root of 9, which is 3, times 2. So we've got 5 plus 2 times 3. Well, 2 times 3 is 6, so I have 5 square roots of 2. Plus 6 square roots of 2, which gives me 11 square roots of 2. Checking it out over here, I'm trying to get square roots of 5. 5 goes into 45, 9. What's the square root of 45? The square root of 9 is 3, so I've got 6 times 3 square roots of 5. Okay, does 5 go into 20? Sure. How many times? 4. What's the square root of 4? 2. So I've got 2 square roots of 5, and I'm going to take that times 7. Well, 7 times 2 is 14 square roots of 5. 6 times 3 is 18 square roots of 5, plus the 5 square roots of 5. 14 plus 18 is 32, plus 5 is 37 square roots of 5. So you see how simplifying makes it a little bit easier, prettier. Okay, so we're going to subtract. Well, 27, I know that's 9 times 3. The square root of 9 is 3. So I've got 3 square roots of 3, and I'm going to take that times 4. Minus 8. 12 is the square root of 4 times 3. The square root of 4 is 2. And then I've got the square root of 3. Now they both have square roots of 3. So I have 12 square roots of 3 minus 16 square roots of 3, which gives us negative 4 square roots of 3. Okay, I'm breaking these down. I know 32 is 16 times 2, so that's 3. The square root of 16 is 4, and then we got the square root of 2. I know 18 is the square root of 9 times 2. The square root of 9 is 3, and the square root of 2. Minus 6, 128 is 64 times 2. The square root of 64 is 8 times the square root of 2. 3 times 4 is 12, square roots of 2. Minus 2 times 3 is 6, square roots of 2. Minus 6 times 8 is 48, square roots of 2. So 12 minus 6 is negative 6. 12 minus 6 is 6. 6 minus 48 is a negative 42, square roots of 2. To multiply them, you just multiply. Outside times outside, inside times inside. So we're going to distribute. 2 square roots of 5 times the square root of 3 would be 2 times the square root of 5 times 3, or 15, minus 2 square roots of 5 times 6. Outside is 2 times 6, which is 12. Inside we have the square root of 5. That's it. Outside times outside, inside times inside. 4 square roots of 3 times the square root of 6. That gives me 4 times the square root of 18. Minus 4 square roots of 3 times the square root of 3 gives me 4 square roots of 9. Well, the square root of 9 is 3. 3 times 4, this is going to be negative 12. The square root of 18 I can break down. The square root of 18 I know is the square root of 9 times the square root of 2. The square root of 9 is 3. And we got the square root of 2. So I have for my answer 12 square roots of 2 minus 12. Can I combine those? No, they don't have the same radicals. Final answer. Now we're going to FOIL. Do the same thing though. The square root of 2 times the square root of 7 is the square root of 14. The square root of 2 times negative square root of 5 is negative square root of 10. Negative square root of 3 times the square root of 7 is negative square root of 21. Negative square root of 3 times negative square root of 5 is positive square roots of 15. Can we break any of these down? 2 times 7 doesn't work. 2 times 5 doesn't work. 3 times 7 doesn't work. 3 times 5 doesn't work. We're done. Same thing here. We're going to multiply the square root of x times the square root of x, and we're going to get the square root of x squared, which is really just x. Then we're going to take the square root of x times 5, which would be the square root of 5x. Then we're going to take negative square root of 5 times the square root of x, which would be negative square root of 5x. Then we're going to take negative square root of 5 times positive square root of 5, and we're going to get negative square root of 25. Well, these middle terms cancel out. That's a positive, that's a negative. The square root of 25 is 5, so this is x minus 5. What does this mean? Well, it means you're going to write it twice. And FOIL, the square root of 2 times the square root of 2 is the square root of 4, which is 2. The square root of 2 times negative x is negative x square roots of 2. Again, we put the radical second. Negative x times the square root of 2 is negative x square roots of 2. And negative x times negative x is positive x squared. So a negative x and a negative x is a negative 2x square roots of 2, because they're like terms, plus x squared. Same thing here. We're just going to end up with a number. 3 square roots of 5 plus 4 square roots of 2 times itself. 3 times 3 is 9. The square root of 5 times the square root of 5 is the square root of 25, which is 5. 3 times 4 is 12. The square root of 5 times the square root of 2 is the square root of 10. 4 times 3 is 12. Square root of 2, square root of 5, square root of 10. 4 times 4 is 16. The square root of 2 times the square root of 2 is the square root of 4, which is 2. So I have 45 plus 24 square roots of 10 plus 32. So that gives me 77 plus 24 square roots of 10.